This is the solution to the question. We're going to start with some hints. So if you've tuned in to get some hints, here's the first one coming up. They're the probabilities on the first part of the tree diagram. Now you have to think very carefully about the next probabilities, so give those a go next. Here come the first selection of probabilities. So if I've chosen a black ball out of the box A and I put it into box B, there are now 8 black balls, not 7. So that's why we move up to 8, but otherwise we still have 3 whites in box B. For the next one, we are taking a white ball out, which means that 3 moves up to 4, but 7 stays as 7. That's the first difficult part of this. Next, you are asked to find the probability that there will still be 6 black counters and 4 white counters in A at the start of this. So what I want us to do is to just think about reality for a second. If I'm taking a black ball or counter from A, putting it in B, I need to take a black counter from B and put it back in A for them to be the same number of counters as there was at the beginning. So that's my one route that I know will work. I'll take out a black and I put a black back in. If I took out a black and put a white back in, that would change the numbers, so I don't want to take that route. If I take out a white and put a black back in, again, that changes my numbers of blacks and whites in my first bag. So if I take out a white but then put a white back in, that's the other way that I can have the same number of blacks and whites in that first box in box A. So I'm going to find out these two probabilities, add them together, and combined they give me my answer. So from here, it's a pretty standard question, but labelling that tree diagram was difficult, and recognising that it was black, black and white, white were the two probabilities you were after, that was difficult also. But this was perfect for a second starter, because if you could do it, you are really doing well. If you could get the tree diagram labelled, also you've done really, really well. If you are after the black, black, white, white probabilities, even if you mislabeled everything, you are doing well. This is an extremely difficult question, and it came for the second starter for an important reason. I wanted, if you're working fast, to push yourselves onto this kind of question. We will have a quick look at the mark scheme for this, because it's worth literally double as many marks as the previous. First 2 parts of your tree diagram earn marks. They didn't on the previous one. All of the remaining probabilities needed for the second mark. For the 3 method marks, what you're doing is multiplying and adding the 2 correct probabilities, working your way through the probability tree, and arriving at your answer 64 over 110. Those are the marks. It's worth looking at a mark scheme every now and then just to see how things are done behind the scenes.